Alright, so normally I do this in person, but we're doing this online. We're going to go over the functional groups and how to memorize them and what ways you should work on memorizing them, right? So we're going to start with a three-stepper, right? We have there's three base out functional groups to memorize, right? We have, and we're gonna start here. This is a carbon bonded to just other carbon, single bonded to other carbon, right? This is alkane. These are alkanes, right? These have single bonds. Let me turn off this. Let me mute that. Stop watching. Um, these are alkanes, right? Then we have a carbon bonded to an alkyl halide. This is an alkyl halide, is what this is. It's a single bond to a halogen or a other, what do you call it? It's a single bond to a halide, and they are called alkyl halide. The important thing about everything you see here, this is an alcohol. It's a single bond to an OH group. This is a amine. And this is an ester. Yeah, this is an ester. The thing that's important to remember about all of these all of these five components is that, one, they all have single bonds, right? So alkanes, single bonded carbon to another carbon. Alkyl halide, single bonded halide to a carbon. Alcohol, single bonded OH group to a carbon. And amine, single bonded nitrogen to a bunch of carbons. Ester, single bonded oxygen to two carbons. That's the difference between ester, and this actually might be an ether. Let me make 100% sure. But this is the that describes this group. We're pretty much looking for single bonds here, and you can tell if it's single bond just carbon and hydrogen, alkane. If it has a halide, alkyl halide. If it has a halogen, alkyl halide. Alcohol OH group. The OH group in single bond makes the alcohol. Amine, nitrogen single bonded. Let me add that lone pair here. Ester, oxygen single bonded, but it has two single bonds. And that'll be important because we're going over to the double bonded portion, right? Which are, we just did alkanes. These are alkenes. Double bonded to carbon, right? And I match these with, this is an amide. This, okay, going from left to right, right? This is going by level of carbon, right? We're going from an aldehyde, which I'll explain these all later. Aldehyde, ketone, carboxylic acid. This is carb acid. In this I think is this is an ester. The other one I have over there is an ether. Let me make sure. Yeah, this is an ester. And that R, if you're wondering what R groups are, they're just any carbon-containing compound. So R just means C, but it's a C compound. It doesn't just mean C. It can be C bonded to a bunch of other stuff. It can be C with a bunch of other functional groups. But this is an ester. This right here, I sometimes get these confused, is an ether. Ether, right? But here we have aldehyde, which is these are all described by amide, aldehyde, ketone, carboxylic acid, and ester, all described by a carbon, which is what these bends mean. Every bend that's unmarked will mean a carbon. So this is carbon, double bonded to oxygen, which is why it's so different from ether, which is just single bonded, 2 single bonds. This is a double bond to oxygen. Aldehyde, ketone, carboxylic acid, and ester and amide are all pretty much an alkene, but you chop off the other carbon and you replace with an oxygen. In amide's case, you have a nitrogen group. In aldehyde's case, you have a hydrogen group and a carbon group. Ketone, 2 carbon groups. Carboxylic acid, carbon and oxygen. So it's like a carbon and an alcohol group. And ester, it's pretty much an ether, but it's next to a double bonded oxygen. Right. And then memorize. It's easier to memorize those together. So when you study alkene, amide, aldehyde, ketone, carb, ester. These aren't super great to study, but you're gonna have to memorize them if you want to be a chemist. Alkyne. Now we have alkynes. Alkynes are, what do you call it? Triple bonds. That's it. And there's very little stuff you can actually do with these, because an alkyne can either be bound to a carbon, a hydrogen, or something that can form a single bond with carbon and be stable. So maybe a halide. But normally this will be really weak and it'll be an electron withdrawing group. So normally you'll only see a carbon or a hydrogen there. This is a nitrile. And the trial describes the triple bond. This is the only other thing that you can have with the triple bonded to a carbon. This is the only other one. You don't really have, well, it's not exactly the only other one, but as far as your organic chemistry is concerned, this will be a triple bond to your carbon. Then we have unsaturation, right? So with an amide, right? An amide, let me select. Let's take that amide. Control V. Our amide has an R group. If we take away that R group and place an H here, this goes from a 1, 2, 3. This becomes a secondary amide. Sec amide. Why? Because it's only connected to 2 carbons. If we take away both, this becomes a primary amide. Why? Because it's only connected to 1 carbon. Those are important. Those are important rules for this. And the same thing can happen in quite a few other things. The secondary, when we talk about primary, right? Secondary and tertiary. It describes the number of carbons attached. So let's take this. Let's say our central atom will be X in each of these cases, right? In the case of X, it's only attached to 1 carbon. In the case of X at secondary, it's attached to 2 carbons. And let me use in the case of X at tertiary, it's attached to 4 carbons, or 3 carbons. And why don't we do quaternary? Why don't we have a quart? Because nothing in organic chemistry, right, can form a carbon bond. There still needs to be a hydrogen here for it to be sec or primary. If you have a carbon bound something bound like this, It's going to be very unreactive, and it's not going to be polar or have a lot of characteristics in organic chemistry. Also, outside of carbon, right? In organic chemistry, outside of carbon, nothing can form. Nothing has enough electron shell, and you need to have a d shell in order to form more bonds than four. So in inorganic chemistry, you can have all kinds of crazy stuff. In break octet, have fun breaking octet with up to heptoxides and stuff. But in here, you won't have that you won't have that issue because we're in organic chemistry. We're limited by the carbon, the power of carbon. So that's this. That's how these are the functional groups, and that's an easy way to group them and memorize them. You memorize them as what do you call it? You memorize them as you memorize the alkanes. You memorize alkane, alkyl halide, alcohol, amine, ether. All of these are single bonds. You memorize alkene, aldehyde, ketone, carboxylic acid, ester, and ester. And my handwriting's horrible, but leave it alone. I'll try and get a touchscreen so I can at least write a bit straighter in the future. But I'm doing this with mouse, and I'm Lispy Jimmy and Slippy Hand. So, and then we have amide. We'd have amide here, but I've shown you that earlier. And then for tertiary or triple bond, we have alkene and nitrile. Those should be the most common functional groups you'll see, and that will be the easiest for you to remember. So have a nice day. That should be it for this video.